All right, so the first thing to notice about this question is they are trying to trick us right off the bat. If we look at the question itself, it wants to know what's going to weaken the team's hypothesis. This is unusual. The SAT does do this, but most of the questions like this are going to be support questions. We need to support the hypothesis, support the claim, but occasionally they throw this curveball at us and they weaken it, which is why we always need to read the question. I know that sometimes in my videos, I kind of skip that step, but I'm assuming you've done that on your own and just don't want to waste your time. But when it counts, it really counts. We've got to be careful here because if we don't pay attention to that word, we might end up with a choice that supports the passage. There's probably some traps in here that would support the hypothesis, and then we'd be really tempted to pick those. So let's try to get a very simple version of this hypothesis. We don't need to understand the science very deeply. We just need to kind of get the rough sketch. So let's see. Icebergs generally appear to be mostly white or blue, depending on how the ice reflects sunlight. Ice with air bubbles trapped in it looks white because much of the light reflects off the bubbles, so that's a fact. Ice without air bubbles usually looks blue, so without is blue, because the light travels deep into the ice and only a little of it is reflected. However, some icebergs in the sea around Antarctica appear to be green. One team of scientists hypothesized, so here's where it starts to count, right? Everything before that was just facts to set up. This is what we have to weaken. One team of scientists hypothesized that this phenomenon is the result of yellow-tinted dissolved organic carbon in Antarctic waters mixing with blue ice to produce the color green. So, okay, this is a great example of how our scrap paper can be so helpful. Let's just summarize this very simply, right? What they're saying is yellow carbon plus blue ice equals green, what are they, bergs? Like bergs? Icebergs. So it's a formula, it's a math formula, right? So if we want to weaken this, basically it's probably going to be the case that we attack one of the pieces on the left, right? Either something about the yellow carbon or something about the blue ice. Something about that is probably wrong, and then we would not necessarily get green as a result. So let's see if these choices have anything to do with what we're talking about. A, white ice doesn't change color when mixed with dissolved organic carbon due to the air bubbles in the ice. Well, notice that white is not part of our formula here. So how would that weaken the formula if we're talking about white ice? This just seems like a totally random thing. It's not part of our summary. It's not part of our equation. So it's probably not part of our answer. Even though weaken is what we want, it just has nothing to do with it. It doesn't weaken it to just throw out a random fact. B, dissolved organic carbon has a stronger yellow color in Antarctic waters than it does in other places. It might be a stretch, but this feels like it's maybe supporting the hypothesis a little bit, right? Because they're saying specifically that Antarctica is where the green icebergs happen. So if there was more of this yellow carbon in Antarctica, then it seems like that's adding to our equation, right? It's saying then that's more likely to produce the green icebergs because there's more of this yellow carbon in this specific area, whereas other areas probably don't have as much yellow carbon, according to this choice, and therefore probably don't have the green icebergs. So this might be a little bit of a trap. I think it still requires a lot of thought to even come to that conclusion that it's a trap, but I think I see what they're doing here. It's trying to mess with us in that way, but also just remember, like, are we really talking about other places here? Is it really about Antarctica specifically that we care? That makes me nervous as well. So I think it's a trap, but let's keep reading. C, blue icebergs and green icebergs are rarely found near each other. Well, okay. That seems like would also support the hypothesis a little bit, right? Because if you're in Antarctica, you probably wouldn't have a lot of, according to choice C, then it would be rare to have blue icebergs because the water has this yellow stuff in it that's going to make all the blue icebergs actually green icebergs, right? It says, because, right, the blue ice plus the yellow carbon is what makes it green. So if it were mixing with the same water, then yeah, you probably wouldn't get random blue icebergs because it's the same water, so it would all be yellow. Again, that's maybe a bit of a stretch to show you that something is a trap, but yeah, that's kind of what I think they're going for here. So let's see if D is right or any closer, because maybe I'm misinterpreting these choices. D, blue icebergs and green icebergs contain similarly small traces of dissolved organic carbon. So here, what they're saying is they're basically knocking out the yellow carbon. They're saying that blue and green have the same amount of this yellow carbon. So if the blue and the green have the same yellow amount, then they shouldn't be blue and green, right? Or at least something else should explain why they're different colors, right? Basically, this choice is weakening the hypothesis by saying that the carbon does not matter. The carbon is not affecting the color, because if blue and green have the same amount of carbon, then that's not what's making them blue and green. It's something else. So I still think that requires a little bit of thought. This is a tough question. So maybe this is one that you would kind of intuitively know as you're doing it, like, oh, I'm a little lost here. I might need to come back. But notice that if we have that summary to go back to, this little equation here, it's a little easier to just notice that choice D is really the only one that kind of talks about one of the pieces of that, right? The yellow carbon, that's the thing that's supposed to make it green. It's the only one that's talking about that, right? So, or I guess B is too, but that part there, I'm nervous about why we talk about different places. That seems strange. So D is the answer, just to be clear, D is the answer. But I do think that this is a hard question. And yes, even in the easy module, you will have questions that are difficult. So, all that means is try your best. And if you do hit things that are hard, don't get caught up in them. Pick an answer that you like, bookmark it so that you can come back, but keep going, because there are going to be easier questions later. And your job at the easy module is just to get everything as much as possible correct. No careless mistakes, no running out of time. So you don't want one hard question smack in the middle of the section to make you lose so much time that you can't get all those easy ones at the end. So you got to budget your time. And sometimes that means just picking an answer and moving on. You can't reread 100 times. You can't just try to get unconfused over the course of 5 minutes for one question. You just need to kind of pick something, place a smart bet, and move on. You can always come back with more time, but if you run out of time, that's it. You can't get to the questions that you didn't get to. So pacing strategy, very important no matter what module you're in, but here especially, don't get bogged down in difficult passage questions.